So friends, the topic for today's discussion is label of significance. So first of all, we have already seen what is test of significance. Once again, we will just see what is test of significance. So what we are doing, we are seeing the difference between the sample mean and the population mean, or the sample parameter and population parameter with certain statistical procedure, and we find out whether this difference between the sample mean and population mean is true or not. And what are those statistical procedure? The statistical procedure are either Z test, T test, chi-square test, F test, or any other test. Regarding this test, we will be saying it into the later classes. So we have to decide whether this difference between the sample mean and population mean is true or not. So for that we have to do certain statistical procedure, and after this statistical procedure we are getting certain value, and then this value we have to interpret with this value, and for that interpretation we need the level of significance. So the next one is, what is level of significance? So level of significance, this is very important definition of level of significance, which here I have depicted in the pictorial form. So what is level of significance? It is a value of chance or value of probability. So this is a value. Level of significance is a value, and value of what? Value of chance. So what chance? The value of chance, which is also called as line of demarcation. So here you can see the line of demarcation. Line of demarcation between acceptance of null hypothesis and rejection of null hypothesis. So this is a value of chance, which is lines of demarcation between acceptance of null hypothesis and rejection of null hypothesis. So if somebody is asking what is level of significance, so it is a value of chance of line of demarcation between acceptance and rejection of null hypothesis. So the permissible value of probability above which we do not reject null hypothesis. So this level of significance is also a permissible value of probability. We have already discussed it is a value of chance or probability above which we do not reject null hypothesis. That means either for rejection or acceptance of null hypothesis, we need the value of probability or value of chance, that is called as level of significance. So about this in the hypothesis we have already seen in the last class. Now the maximum probability of committing type 1 error. So regarding the errors, different types of errors, we will be discussing it into the next class. So as of now, just you have to remember that maximum probability of committing type 1 error is known as level of significance. This is the another definition for level of significance. And in practice, in biological sciences, usually we are fixing level of significance as 5% or 1%. So what is 5% and 1%? Just you remember this, just you note here 5% and 1%. We will be discussing it into the later slides. So the question is how to decide whether there is close agreement or not, whether the null hypothesis is true or not, whether the population parameter is close enough with the sample parameter or not, or the sample parameter that we have estimated is close enough with population parameter or not. So how we will decide? So for this, some test criteria is calculated. We have already discussed, and estimated value of test criteria is compared with table value of the test. So this estimated value of test criteria, we will be comparing it with the table value. What is table value? So table value is the probability distribution table. We have already discussed when we were discussing about the probability distribution. So we are having probability distribution table, and on that probability distribution with certain level of significance, we will be seeing the value of table, and we will be comparing our calculated value with the table value, and then we will decide whether our calculated sample parameter is close with the population parameter or not. Now let us understand it with this example. The example on adult body weight in pattern body sheep. So the population mean of adult pattern body sheep is given as 40 kg and the standard deviation is 10, and from this population we have taken a sample of 25 sheep body weight of 25 sheep. Now based on this we want to test whether the sample which we have taken and the sample parameter that we are estimating is close enough with the population parameter or not. So what is our hypothesis? The first null hypothesis is mu is equal to 40 kg. That means the sample that we have taken is also having mean of 40 kg, or it has been taken from the population which is having mean of 40 kg. And alternate hypothesis is obviously it is telling that mu is not equal to 40 kg. So now we will be seeing about the standard error of the sample. So how we will be estimating the standard error? The sampling distribution of x bar is normal. Why it is normal? Because we have taken 25, number of sample is 25, which we are considering it as a large sample. So large sample we are saying that, or we have already seen that when the sample size is large, it is discussed with the normal distribution table, or it is following the normal distribution. So the standard error of this sample will be equal to standard deviation divided by under root n. So here the standard deviation is given as 10 and the sample size was 25, so under root of 25 is equal to 5. So standard error of this sample is 2. So just remember the standard error of the sample, it is 2. Now we choose the value of x bar. So now we use the value of x bar. We have to decide, or we have to, I have taken it indirectly. Actually in practice you will get the value of x bar. You will be calculating x bar and you will get the value of x bar. But here indirectly, for better understanding, I have taken at what value of x bar we will be rejecting the null hypothesis or we will be accepting the null hypothesis. So we choose the value of x bar which will cause us to reject the null hypothesis. So what value of x bar will cause us to reject the null hypothesis? Suppose we decided to reject the null hypothesis if mean is more or less than 1.96 standard error of x bar. So 1.96 multiple of standard error. So what was the standard error? It was 2. So 1.96 into 2 is equal to 3.92 kg from mean. 3.92 kg from mean. So how this 1.96 value is coming, that we will be seeing in the next slide. As of now, you just remember, okay, we have taken a value of x bar as 1.96 into standard error and above or below which we will be rejecting the null hypothesis. So what is here? You can see we accept null hypothesis if x lies between 36.08 and 43.92. How this 36.08 and 43.92 come? That means 40 plus minus 3.92, 40 plus minus 1.96 standard error. So 40 minus 3.92 is equal to 36.08 and 40 plus 3.92 is equal to 43.92. So whenever we are applying a test statistics and we are getting the value of that statistics, suppose we got the value of that particular test as 42 kg. So we will be seeing whether this 42 is lying between 36.08 and 43.92. Oh yes, it is lying between the 36.08 and 43.92. So we will be accepting the null hypothesis. But suppose the calculated value is coming 45 kg. So 45 kg is beyond 43.92. So in that case, we will be rejecting the null hypothesis. Similarly, instead of 1.96, if we are taking 1.645, so in that case 1.645 into 2 is the standard error, so it will be coming around 3.29, and the range will be 36.08 to 43.29. So the acceptance range will be between the 36.08 and 43.29. So these two values, 1.96 and 1.645, how these values are coming? So I think other things you have understood. Only we have to understand how this 1.96 and 1.645 is coming. So whatever value we have fixed, we have to multiply it with standard error, and then we have to subtract and add it into the population mean, and that will be your interval between which, if your calculated value is lying, then we will be accepting null hypothesis, and beyond which, if your calculated value is coming, then we will be rejecting the null hypothesis. So now, how this 1.96 and 1.645 is coming? So this is the table. This is the T distribution table, that is normal distribution. T is the normal distribution table. Here you can say the one side is degree of freedom. So how this table value we will be seeing, we will be again seeing when we will discuss about the different test criteria. That is, we will be discussing about the T test, F test, Z test, chi-square test. At that time also we will be seeing the table. So just you remember, in one side there will be degree of freedom. Degree of freedom we have already studied, and then you can see this is the two-tailed test and one-tailed test. So in front of two-tailed test, these are the level of significance: 10%, 5%, 2%, 1%, 0.2, 0.1%. So generally in biological sciences, we can take any level of significance, but in practice we are taking the level of significance as either 5% or 1%. So here you can see that at infinite, if your sample size is very large, the degree of freedom will be around infinity. So at 5%, you will see at infinite degree of freedom, at 5%, you can see 5% two-tailed test. I am talking about what are the one-tailed and two-tailed test we will be discussing in the later part of this lecture. So this at 5% you will be seeing that the value is 1.96, and 10% the value was 1.645. So these value come from this table. So I think now it is clear how this 1.96 and 1.645 value is coming. It is coming from the table, that is the value at 5% level and the value at 10% level. If you see at 1% level, it is 2.576. In the later slides we will be discussing this value also. So I think it is now clear to you. Now you see a two-tailed test. Now about the two-tailed test of hypothesis. So a two-tailed test of hypothesis will reject the null hypothesis if sample statistic is significantly higher than or lower than the hypothesized population parameter. So you have calculated the value 1.96 into standard error. So you have to, if it is a two-tailed test, then you have to add and subtract it from the population parameters. The population parameter, that is population mean, was 40. So you have to subtract 40 minus 3.92, and you have to add 40 plus 3.92. So you decided the value 36.08 to 43.29 or 92, 43.92. So these value is suppose this value, if you are seeing on setting it on the graph, these value will be lying from here to here. So here you can say it is 36.08, and here it will be 43.92. So if your calculated value is lying in between these two values, then we will be accepting the null hypothesis. But in case of two-tailed test, the rejection region will be lying on both the sides of the graph, both the sides. So if it is 35, that means it is falling in this area. If your calculated value is 35, then it is falling in this area, and if it is 45, then it is falling in this area. So in either of the cases, we will be rejecting the null hypothesis. So this is about the two-tailed hypothesis. Thus in two-tailed test, the rejection region is located on both the tails. Okay. Now if we are testing a hypothesis at 5%, so this is the case of 5%, the label of significance, the size of rejection region is 0.025. So here you can note the rejection area is 0.025 on both the sides, 0.025 on both the sides. And if we see the normal distribution probability table, we find that an area of 0.475 correspond to 1.96 standard error on each side of the mean as acceptance region. So 0.025 is the rejection region on both the side of mean. Okay, and 0.0475 is the acceptance region on both the sides of mean. So here you can see a better graph. This is the another graph. Here you can see this is the rejection region of our example. 36.08 is the lower limit and 43.92 is the upper limit. This we have already discussed. It is the acceptance region, and this is also called as confidence limit. Confidence limit. So this is minus 1.96 into standard deviation, and this is plus 1.96 into standard deviation. That is, it is discussing at level of significance of 5%. So 5%, the rejection region is 0.025 on either side. That is rejection region or critical region, and acceptance region is 0.475 on both the sides of mean. That means in total this is coming around 95% or 0.95. So 0.95 is the acceptance region in two-tailed test on both the sides of the mean. Now you see, suppose we want to make our decision more stringent. More stringent means now from 5% we are fixing the level of significance as 1%. That means the acceptance region we are increasing from 95% or 0.95 to 0.99. That means we are making more stringent. That means we will be rejecting null hypothesis only, means the chance of rejection of null hypothesis is only 1%. 1% of the region of 1% of the area of normal distribution curve. So we can do it by reducing the size of rejection region. So level of significance may be fixed at 0.01, that is 1%. That is 1%. So here in this graph you can see in two-tailed test, this is about the two-tailed test. So this rejection region is 0.005 on both the sides. 0.005 on both the sides, and acceptance region it is 0.0495 on both the sides of the mean. So in total it is coming around 0.99. Okay, and 1%, the value of 1%, if you remember, it was 2.575. Here it has been taken as 2.58. So 2.58 into standard deviation of mean. So this is the rejection point, or this is the point beyond which we will be rejecting the null hypothesis. Now if we see the normal distribution probability table, we find the area of 0.495 correspond to 2.58 standard error on each side of the mean, that we have already seen. It is clear from the figure that as we decrease the size of rejection region, as we are decreasing the size of rejection region, that is from that is means 5% to 1%, we increase the probability of accepting the null hypothesis. So if we are decreasing the rejection region, we are increasing the chance of or probability of accepting the null hypothesis. That means probability of accepting the null hypothesis means whatever treatment that you are going to test, this thing you will be remembering and you will be understanding in a better way when we will be discussing the test or practical example on the test. So just you remember, as we are, or you have seen already, as we are increasing our decreasing our rejection region, the acceptance region will be increasing and chances of getting null hypothesis accepted will be more. Now the two-tailed test is appropriate if rejection region may lie on both the sides. So when you will be needing the two-tailed test, so two-tailed test will be needed if your rejection region is lying on both the sides. How? Just see one example. Suppose your null hypothesis is that the average income per household is rupees 1000. So you did survey, and in a population, now you have taken a sample and you are assuming that the average income of household is 1000 rupees. The alternate hypothesis is the average income per household is not 1000. So the alternate hypothesis is that it is not 1000. So what it may be? It may be either greater than 1000 or less than 1000. So if it is greater than 1000 or less than 1000, that means we have to go for two-tailed hypothesis testing. Two-tailed hypothesis testing, because the rejection region may be on both the sides. So the rejection region would lie on both the sides because we will reject null hypothesis in either too far above 1000 or too far below 1000. So now I think you have understood why two-tailed test is necessary. So we will be seeing one example of one-tailed test also. Then you will be understanding it in much better way. So this is the example of one-tailed test. Here the rejection region will be located in only one side. So rejection region will be located on one side. We will be seeing the graph for it, and that will be either on left side or right side depending on our alternate hypothesis. So whatever alternate hypothesis we have assumed, based on that the rejection region will be either on left side or right side. So the same example, you see the alternate hypothesis, null hypothesis, it is telling the average income per household is it is greater than 1000 rupees. So our null hypothesis is that it is average income is greater than 1000 rupees. So what will be the alternate hypothesis? Alternate hypothesis will be always that it is the average income per household is rupees 1000. So alternate hypothesis is rupees 1000, but null hypothesis it is greater than 1000. So rejection region now it is always on one side. That is on what we will be doing, that if the income is coming lesser than 1000, then only we will be rejecting the null hypothesis. If it is greater than 1000, we will be accepting the null hypothesis. That means our rejection region will be lying on one side only. So here we will place all the alpha risk means level of significance risk on the right side of the theoretical sampling distribution, and the test will be one-sided right tail test. So here the rejection region will be on the one side only. That is why it is called as one-sided right tail test. Just see, this is the example of one-tailed test. Here you see the rejection region is on left side, so it is left-sided one-tailed test, and here it is on right side, that it is called as right-sided one-tailed hypothesis testing. So this was about the one-tailed test. Now in summary you can say, suppose we have population with mean as mu0, mu0. Suppose you are having population with mean as mu0. So what will be the null hypothesis? You have taken a sample and now you want to test whether your sample mean mu is equal to mu 0 or mu naught. So an alternate hypothesis, what could be the alternate hypothesis? So what it is telling that sample mean is equal to population mean, but alternate hypothesis, it is telling, first alternate hypothesis, that mu is not equal to mu 0. Mu is not equal to mu 0. That means it may be either greater than mu 0 or it may be lesser than mu 0. That means it is telling both the things. Either it may be lesser than or it may be greater than. Second alternate hypothesis may be that mu is greater than mu naught. That means sample mean is greater than population mean. So it is one sided. Another hypothesis, third one, mu is lesser than mu naught. So this is also a one sided test. So now you can say that the HA alternate hypothesis in first case is known as two-tailed alternative. First case is two-tailed alternative, and the alternatives in second and third are known as right-tailed and left-tailed. That is, these two are one-tailed, right-tailed and left-tailed. So now it is clear to you what is one-tailed test, what is two-tailed test, what is level of significance, how we are fixing the level of significance, and which one is more stringent level of significance. So this was all about the level of significance. In next class, we will be seeing about the different types of error that we are committing while testing the hypothesis. Thank you.